Okay, so I was looking at this thing today, the NTI DP8K-FOCMP-30M-MM.
Right.
And I have to be honest, I got stuck on the price. It's a 30-meter DisplayPort cable that costs $300.
Yep.
For that money, I could buy a decent monitor. I mean, why on earth would anyone pay that much for just the wire you plug into it?
Yeah, that's a fair question if you're, just connecting a laptop to a monitor on your desk.
Which is what most people do.
Exactly. But this isn't for that. You're not paying for the wire. You're paying to beat the laws of physics.
Physics? It's just sending a video signal, isn't it?
Well, think about the bottleneck. We're talking 8K resolution.
Okay.
That requires pushing 32.4 gigabits of data per second.
Wow.
Now, trying to shove that much information down a normal copper wire over 30 meters, it's like trying to drain a swimming pool through a drinking straw.
Okay.
The signal just dies. The electrical resistance is too high.
So standard copper effectively just chokes at that distance.
Completely.
Yeah.
And that's why this is an active optical cable. It basically abandons electricity for the data and switches to light.
Active. I assume that just means it's directional, right? Like you have to plug a specific end into the TV?
That's part of it, yeah. But active really refers to the silicon inside. This is not just a passive rope of wire.
What do you mean?
Inside the actual connector heads, there are chips and lasers. It takes the electrical signal from your computer, converts it to light pulses, shoots it down fiber optic glass.
Wait, they're actual computer chips inside the cable heads?
Exactly. It's a localized computer system disguised as a cable.
That definitely explains the price. But let's talk performance. The documentation is all about zero signal loss, perfect fidelity.
Right?
But then, buried further down, it lists DSC 1.2, which is compression, and FEC, forward error correction. If the fiber is so perfect, why does it need error correction?
That's a great question. It's about the nuance of high-speed data. Even with fiber, when you're moving data at 32 gigabits per second, things can happen. The active chips aren't just converting light, they're constantly monitoring the signal's integrity. FEC means the cable is doing math in real time to make sure the data arriving is identical to what left.
So it's not that the fiber's failing.
No, not at all. It's that the system is guaranteeing perfection.
It's self-policing the signal.
Precisely. And you absolutely need that when you're pushing 8K at 60 hertz, or for gamers, 4K 120 hertz. If you drop one packet at those speeds, you get a blackout. This prevents that.
You mentioned it uses fiber for the data, but I see it also has copper cores inside. Why mix them?
That's more of a quality of life thing.
How so?
Well, pure fiber cables, they usually need an external power source, like you'd see a USB plug hanging off the connector to power everything.
I've seen those.
Because glass can't carry electricity. By keeping a few copper strands, this cable can draw all the power it needs for those lasers and chips straight from the DisplayPort itself. It keeps it plug and play.
Okay, so we have delicate glass fibers, lasers, microchips. This thing sounds incredibly fragile. But then I see it's Plenum rated. Isn't that for, like, rugged construction?
It is. You have this incredibly high-tech, delicate interior, but it's all wrapped in a CMP-rated jacket.
And CMP means?
It means it's fire retardant, and it emits low smoke. So you can drag this through the air ducts above a drop ceiling, the plenum space, and it meets really strict building safety codes.
I suppose it really matters if you're wiring, say, a hospital or an airport.
And that's exactly where these end up. In fact, because it uses light, it's immune to electromagnetic interference. You could run this cable right next to an MRI machine or through an airplane's avionics bay, and the picture won't flicker. A copper wire would act like an antenna and just pick up all that noise.
So really, you're paying for the guarantee that the image will get there perfectly, regardless of distance or environment.
Exactly. It's a specialized tool. If you're just watching YouTube on your desk, it's massive overkill. But if you're a radiologist looking for a tiny fracture on an 8K display, good enough isn't an option.
It definitely blurs the line on what a cable actually is.
That's the thing that sticks with me. We used to think of cables as just dumb pipes,
Yeah.
But looking at this with its own firmware, its own processing, is it still just an accessory? Or is the intelligence of our devices slowly leaking out of the box and into the walls?
I'll never look at a wire the same way again. Thanks for tuning in to this deep dive on the NTI DP8K.